Okay, let's do it. Design time, episode 13. Last episode, I basically had an issue where I wanted to make a control arm that was adjustable for the display. I really didn't want to buy or use some kind of a threaded body, some kind of a jack screw, or I wanted it to all be 3D printed. So this is what I came up with. And there is a ton of engineering and design into this little control arm. And it's extremely satisfying to play with. It works really, really well. And I'll give you an idea on all the little things that matter when it comes to making something like this. I have made a lot of things like this, but they all have different mechanisms. So the mechanism in this has to do with this clip. And if you look at this clip, you'll notice that the corners are taken out of it. And the only critical dimension is the width of it this way, and it's actually quite a loose fit this way. And there's a reason for all of that. It's because that clip is what keeps these fingers tight around this this piece here. And the reason why we're printing these on these angles, 45s, is because the printer does not need supports for anything around 45. So I can print these without any supports. And you'll notice that every time I move a clip, this actually expands. And that is the mechanism that actually keeps this in place. As soon as I find a position and slide this clip, it no longer moves because it cannot expand and climb over the next peak. So I haven't actually seen this anywhere, and it really was a brain-racking design process, but now I can get infinite range and I can lock in whichever position. And then also this green line represents the OEM manufacturing length of the scaled down control arms. And then there's one other thing that I really went above and beyond for doing. I made this a parametric model, so that what that means is I can change one dimension, which is the dimension from this point to this point, and everything in this will adapt its size while maintaining all of the other parameters. So the center point of this line will continue to be in the center of the adjustment range. So I'll actually show you how that works here. I'm gonna just take one of these control arms. I'll copy it and I will paste it somewhere else. And let's just put it over here for now. What's gonna happen if I go into my parameters, find the arm I just created, and there's one dimension that I need to adjust. I'll use my mouse. This is the factory control arm length times by 0.4, because this entire thing is scaled down 40%. And I'm basically going to change the formula, and I have a new control arm that I just measured, and it is 12 inches long. And I'm going to input that. So you just saw it change behind here. I now look at this. I guess the only thing I would need to move is something that I added right at the end, and it is the number. The number needs to be dimensioned to this point. So I'll actually fix that. But otherwise, you can see the arm completely changed. And if I Control Z it, you can see how everything changes all on its own. And this is designed within the parameters. And this is what parametric modeling is all about. The only thing I need to fix is the 2. So, and then we take it and apply it to the entire model that I created. I just finished this actually. I printed it. Just noises everywhere, eh? I don't do well with all these noises. Like, what is that? You know what that is?
Yeah.
This is the toe arm, and I'm now going to install it onto the model. Again, I found these balls on Amazon. They are 9mm balls designed for furniture decor. You put them on light fixtures. Now that we have all of this installed, I can simulate. I'm actually going to take the shock right off because it simulates better without it. But this is the shock mount, again, in the OEM positioning. And this is the display. I used a different form, which is called automated modeling, where I specify a bunch of avoidance regions and geometry to select, and I basically create a functioning product out of using automated design. I did have this designed manually and it worked fine, but it took almost 7 hours to print. So now that I did automated modeling, I can get all the strength and structure where I need it. And the print time is now 4 hours and 40 minutes for this. And I'll show you quickly a really quick synopsis of what automated modeling looks like. But let's take a quick look at this display first. This represents almost all BMW 5-link. Even the new BMWs, even the M2, M3, even the M4 GT3, they all use a 5-link in the rear. From the lowest model all the way to the highest, even on their all-wheel drive vehicles, this represents all of them pretty well. Now, dimensionally, there may be some differences. This is an exact replica of an E80 or an E90, but the consensus on how and what does each control arm control is going to be the same. So I can show you guys that by simply loosening the clip on one of the control arms. This would be the lower trailing arm. And then you can really start to see what lengthening and shortening that trailing arm does. And we can find the neutral point because I put that into the design if we want to lock it back in and try adjusting something else. So if I loosen the upper clip, let's take a look at what that does. Is that good view, Jack? Yep. So sometimes you would really think this arm typically would be good for like a camber adjustment, but really in reality it does way more than camber. It rotates the knuckle a lot. It's going to be changing your bump steer. It's going to be changing several things. Your wheelbase, your track width, your scrub, your anti-squat. It's going to change all those things anytime you make a small adjustment on these control arms. So having a display like this really illustrates what these things do. That's the toe arm, and it does do primarily toe, but you can see the artificial rotating point is kind of found between these ball joints in line here. And you can kind of see that as I mess with the toe arm. And the coolest thing is when you lock all these arms in, I was really wanted a really strong design. When you lock all these arms in, you can actually push and pry off of this knuckle like pretty hard with quite a bit of force. And it really does behave and handle quite well. These ball joints and how they clip in is really smooth. I'm really happy with how this came out. I'm probably going to just do an automated design on the knuckle. I mean, at some point I could probably run a course and do these types of things almost live on like a Twitch stream or something, and just like, I'm going to design this, people can log on and watch it because I'm going to do it anyways. I would really have to get into the flow of like how to do that but not being interrupted all the time. But yeah, I'm going to do that next, and then this is going to be complete and ready to basically purchase this whole thing from us, or we're going to have this as a downloadable file, which we just released our educational displays as downloadable. All of these, if you haven't seen, just pass me just a couple. Yeah, there you go. So all of these educational displays, and we're going to add to this as well. So far we have Ackerman, motion ratio, roll center. Really, we need to cover caster, camber, toe, all the basics. Just for educational purposes, we take for granted how much that we know and understand by doing this stuff all the time, and how much isn't known, and how much you can learn from practically playing with something. But that is the 3D stuff, really nifty design on the control arms, and I'm going to be repurposing this design and using it for the next 40 years to come. So that's cool. When you come up with something that you know you're going to be using, it's really neat. Let's go over to the computer and take a look at the adaptive subframe. I'm just going to show you quickly how that works. I have all my avoidance bodies, and they look something like this. It's kind of a mess, really, but basically each arm has a range of adjustment. So the adjustment range of each control arm swings in this direction. So each point has that range, okay? And the next points of avoiding would be these points, these blue cylinders. These blue cylinders represent the clearance that I need to put a screw into the subframe with a screwdriver or with a drill. So I wanted room for that. And then my connecting points, if we can hide this component, my connecting points are, that's actually the old subframe. My joining balls, I guess they're part of the component now. Anyways, I had cylinders mounted between these that represented what I needed to join to, and that is essentially what this shape was created. So basically I had a base, this wall, and this wall, and the computer generated a shape connecting all of these cylinders to the base, and then from there I was able to kind of tweak it in form. If you go to edit form, I can click and I can pull and I can manipulate the shape of this. But these are those cylinders, you can see them there. So basically it created a form around the critical dimensions that I needed. This week was a huge, just absorbing a lot of learning. So that was really awesome to mess around with that and have an excuse to do so. But let's move on to race cars and things that we built for race cars. This week we did drag suspension. So we needed to create a solution for guys drag racing Corvettes, and they have a steering rack that's completely in the way. And I can show you all of that with basically bringing in the components. So basically when you have a Corvette, you have an engine, and the front of the engine is right behind this steering rack assembly. And this steering rack assembly cannot be moved if you want to continue to steer your car. So what I did was use what we did in the drift kit, and I designed a rack relocation setup, but this is to maintain factory length control arms, factory length geometry. So that is a BMW rack sitting in the subframe. That is the subframe plate that bolts to the bottom and holds the rack in place. You do need to do a couple modifications, just some, basically cut a little slot for the lines and then grind just a little bit off the subframe right there, and then it fits perfectly. Fortunately, we've done this all before. And on the suspension side of things, let's bring back all of these. Okay, we actually have a full simulation of the OEM suspension, and we can cycle that. Okay, that is not bump steer, that is just the rack actually moving. I can lock that in place for now. Lock motion. Okay, we actually have really good control over bump steer, and that is with a tie rod connecting all the way. Where is it? Down here. All right, so from this, we designed a knuckle adapter that gives us a double shear point, using the ball joint actually as a reinforcement. So I'm going to hide this, and you can see that a long bolt's going to pass through all of these plates, and all of these plates are what brings us to this like 7+ inch drop in the tie rod, getting all of our lines lined up. So basically we need to have our steering rack pivot point line up with our control arm pivot point, line up with our upper control arm pivot point. All these lines need to be in line, and same thing out here, in order for us to have good control over our bump steer and linear movements. So we did all of that. Everything works really, really smooth, really, really nice. The sway bar connects in the factory location. The shock connects in the factory location. We have our shim blocks with our adjustments here. This has actually been built, and I'll show you here in a second. Rain did it in a couple of days. And to further go into the design, I have to open up the steering and show you. So let's move this from lock to lock, and you can really start to see, if I go down in my droop and full angle in my lock, I had to do some wild stuff to get the clearance I needed out of this control arm. And if you look at what a factory control arm would be doing, it would be completely in the way of the tie rod. There's absolutely no way you could do this with a factory control arm. So redesigning that was a must. and making this custom plate alloy steel design was needed. Now we did some other cool things. We have a 3D printed jig block that actually we printed, and it holds the cup at the correct angle for rain. So that was something that we printed and did. And then we handmade some of these parts because Dylan's so busy in the machine shop. But basically we have finalized this design within a matter of a week and produced the kit. And we are now able to ship this to the customer, and he's going to be test fitting this, installing it. And yeah, we're gonna get some good feedback on how this is gonna work for the drag racing community, primarily for them because they're running so much power and so much either boost or supercharger or bigger engines in Corvettes. They'll now be able to do that with the rack relocation kit. Really comprehensive, ton of hours into that, and it looks like this. There is the control arm. It's quite a bit lighter than you would actually think. And these are about to go get powder coated, customer requested black. These holes are primarily for access to the shock, but also used to locate the cup. So that's the main use. And we may be able to run some FEA additionally to this and lighten up the body, but because of what the customer needed it for and what he's using it for, this is what we're looking at. That's really sweet. The adapter for the knuckle is done. We used a factory Corvette knuckle to actually create this, and this is going to bolt on to a stock C6 knuckle. Really nice, a lot better than making an entire knuckle for cost savings and reliability and fitment and everything else. Everyone has these knuckles, they're everywhere. And then the rack plate looks like this. This holds the BMW steering rack perfectly underneath the subframe, and you just have to drill and tap these holes. They're little bosses that are available on the subframe. So that's pretty sweet. And then last week we made some high clearance control arms for a bagged Z06. Those are completed and they look like this. Really, really nice. This was a custom color that the customer had requested. And these are the integrated studs into our Heim joints that we have recently gotten 1,000 of these made, and they work fantastic. They serve the front and the rear Z06, so you can see that the rear uppers have the same thing going on, but they will use the narrower hole position, and that is the high clearance control arms for the Z06. He's also going to be using these shims to adjust his alignment. These fit in both the front and the rear. You can see that is the difference between the two hole positions on the Z06. Would have been lovely if they just did the same front to back, but we know manufacturers just don't do that. You can also use the Heim joints if needed, but these really for accurate alignment, and if you wanted to just tweak a little bit of the rotation of the control arm or anything, you can just use shims on either piece and it's going to be more accurate. It's better to lock these down, keep them where they are, and use the shims from there. So we're providing those. I mean, there's more we could go on and on and on about, but that's probably good. I did make some racing control arms as well for the Corvette, and I did some really neat things with that. We have tubular control arms that we designed. This is actually going to be a 3D printed piece that locates the bungs, and this is a 3D printed piece that actually holds the control arm. Hide one of these bodies. Okay, so it's two halves, you clamp them together. It holds this tube, and then you can run a hole saw through here. That's going to do your first cope, and then you can run a hole saw through there. That's going to do your second cope. So that's going to be, I'm going to build those next week. That'll be really interesting to try. And these are tubular chromoly, 1 inch. We're making specific bungs for it. And we're going to be bending the tubing and using the 3D printed jig to cope and cut the perfect length to make this happen. Obviously, we can do these CNC laser and bent from companies like Bending Solutions, Cage Kits, Rob Parkson, but we don't know the quantity and we don't know the market. So we're building these for a customer that bought them and paid for them, but in order for us to make it a product, we would be buying 50 or 100 of these from Rob, and we just don't know if we have proof that out yet. So this is going to be essentially the prototype, and we're going to build those by hand next week with tons and tons of design time stuff in it. So that was all in the last 6 days, and we had lots of other things going on as well. We've been working on some grip stuff for the 350 that we have in, updating things on the BMW and the BRZ. So yeah, we're getting ready to go to PRI. We're going to be talking to lots of people there regarding all this type of work. So it's exciting. That's going to be the end of this video. We'll see you guys next week for episode 14. And yeah, we're going to keep them coming. Thank you guys for watching. See you on the next one.